Okay, in this video, we're going to be covering logarithms. So quick recap of what a logarithm is. Let's say we have an equation like 2 to the power of 4 is equal to 16. So it's telling us, if we do 2 to the power of 4, we're going to get 16. A logarithm would tell us, to what power of 2 do we need to get to 16? So it's basically asking the opposite question, which we can write as log base 2 of 16 is equal to 4. And the way I like to read this is, how long does it take for 2 to get to 16? And this would tell us here, it takes 4 steps exponentially. So 2 to the power of 4 is equal to 16. And we get back at this original equation. Okay, with that definition out of the way, let's get into some problems. Convert to exponential form. Okay, this is telling us how long does it take for 2 to get to 8? It takes 3 steps. So 2 to the power of 3, or 2 cubed, is equal to 8. Which if we do 2 times 2 times 2, we do get 8, so we can verify this is true. Okay, next one. Convert to exponential form. This one's asking, how long does it take for 5 to get to 125? And the answer is 3 steps. So 5 cubed is equal to 125. And we're done with that one. As you'll see, these ones are pretty easy, not too bad. Okay, and slight note about this one. A lot of mathematicians, since using log base 10 here, this is called the base, this number at the bottom. Since using log base 10 is so common, sometimes they don't even bother writing it at all, like this. So they just write log of 100. And that's the same thing as log base 10 here. Yeah, just one thing to watch out for. If there's nothing there, just assume it's a 10. Okay. So again, this is asking, how long does it take for 10 to get to 100? The answer is 2 steps. So 10 squared is equal to 100. Okay, next one. Convert to exponential form. Okay, and this ln thing, this is the natural log, which is log base e. And if you're curious, log base e is about log base 2.7. 2.7 is just a special number. 2.7, 182, all that. It's a number like pi. It's just a special number. That's a constant. You'll see if you work in statistics or compounding interest. Okay, so with that out of the way, this is log base e of this weird number, e to the 4, is equal to 4. It's telling us how long does it take for e to get to e to the 4? Well, that's just 4 steps, which we'll see is pretty true here. So e to the 4 is equal to e to the 4. Well, that's pretty obvious. And we circle that. That one's done. Next one, simplify. Okay, so for these problems, when we have an addition sign, or we have them inside, like this, log base a of xy, these are the same thing. So when we're dealing with logs, just associate with these plus signs with multiplication. So if we have something like log base 2 of, let's say, 64, that's also equal to log base 2 of 32 plus log base 2 of 2. And this is what I call the product sum rule of logs. And what it says that when you have a product like this inside a logarithm, you can break it down into its factors like this. So you have 32 and 2. And if you want to, you could keep from breaking this down, like log base 2 of 16 plus log base 2, 2 plus log base 2 of 2. So this one broke down into 16 and 2, and this one broke down into 2. Just 2, sorry. Okay. And we can do it the other way around too. If we have a sum like this, we can put it back into a product. Let's just here with this, and they have to be the same base. So A and A, you have to match, by the way. Okay, and next one, with the rule cleared up. Okay, simplify. Log base b of 5 plus log base b of 3 plus log base b of 2. Okay, so remembering that product and sums are associated, this means that we can put all these numbers in one logarithm. This, so we're going to have log base b of 5 times 3 times 2, and 5 times 3 is 15, times 2 is 30. So we're just going to have log base b of 30. Yeah, that's a whole lot simpler. We're done with that one. Okay, now for this one. Simplify. Log base c of xy plus log base c of z. Okay, remembering the rule from the previous problem. When we have a sum here and the same base, we can put them all into one. So we're going to have log base c of xy times z. And remember, if you have multiplication with variables, you can just remove this little dot. Okay, and we're done. It's just log base c of xyz. The next one, expand. Okay, so we're going to have log base 3 of 27x. And let's do the same thing we did in last problem. Associating products and sums. We can break this down into log base 3 of 27 and log base 3 of x. Since 27 times x is 27x. Okay, now we have two separate logs basically. And to simplify the left one, we're just going to ask, how long does it take for 3 to get to 27? And if you know your powers, you would know that 3 to the power of 3 is 27. So this on the left-hand side, sorry, left side, just simplifies to 3. So this is all just 3, since 3 to the power of 3 is 27. And now we're going to add this right side, plus log base 3 of x. And we're done. Okay, next one. Okay, log 4 of x to the power of 3 divided by y squared. Okay, and if you remember that products and sums are associated plus times, then logically minus signs are associated with division. That's how the rule goes. So when we have division, we're going to do the same thing we did here, but subtract instead. So this turns into log base 4 of x cubed minus log of y squared. But we're not done just yet. There's another rule called the power rule of logarithms. And it says that if we have a power like this, we can bring it to the outside. So we're going to have 3 log 4 of x. And for this one, so we have a 2. It's going to be minus 2 log y. Sorry, not log y. Log 4 of y. Okay. And if you're not convinced just yet of this power rule, let's take an example like log 4 to the power of, let's say, 64. You could do it manually, like 4 to the power of 3 is equal to 64. So the answer is 3. Or you could see it in a slightly different way with the power rule. So let's write this as log base 4 of 4 to the power of 3. You can bring this 3 to the front, and you're going to get 3 log base 4 of 4. And we know log base 4 of 4 is just 1. You get there basically with no effort. So it's just 3 times 1. And we get the same answer of 3. Okay. So the answer for this one is 3 log base 4 of x minus 2 times log base 4 of y. Okay. So the next one, simplify log base b of x minus log base b of y. And remembering that minus signs are associated with division, we can just divide x and y. So we're going to have log base b x minus y. Okay, this one's just a little bit easier to reinforce the rule. Okay, next one, expand log base 5 of 25 divided by y. Okay, and again, these division signs, which are called vinculums, by the way, mean division, subtraction. So we're going to have log base 25, or sorry, log base 5 of 25 minus log base 5 of y. Okay, log base 5 of 25 is just 2, since 5 squared is 25. So we're going to have 2 minus log base 5 of y, and we're done. Okay, next one, simplify. Log base 2 of AB divided by C. Okay, first one, it's like we have to apply multiple rules, since we have a product and a division here. Okay, let's do it one by one. So we have log base 2 of, let's use this product rule later. So we're going to have log base 2 of AB minus, use of division, log base 2 of C. And this left one, use the product rule, you would get log base 2 of A plus log base 2 of B minus log base 2 of C. And we're done. Okay, next one. Expand log base 6 of the quantity x squared divided by the quantity y cubed times z. Okay, using the same logic as last time, we're going to have log base 6 of the top and then the bottom. Okay, so the top goes here, and then we subtract the log of the bottom. So log base 6 of y cubed times z. Okay, and we can break down this right side even more. Okay, we're going to need some space. So on this side, we're going to have log base 6 of y cubed minus log base 6, sorry, plus log base 6 of z, since we have a product, plus sign. And then on this left side, we still have log base 6 of x squared. And now for the final rule. Okay, actually, sorry. We're going to put a parentheses here. Since you're subtracting all of this, subtracting this big chunk. And this big chunk is equal to all of this. Okay, so with that out of the way, now we use the power rule. So we're going to have 2 log base 6 of x minus parentheses log base 6 of y cubed log base 6 minus 3 times log base 6 of y plus log base 6 of z. Okay, that's a long one. It's good practice. Okay, next one. 3 times log base b of x. Okay, and if we have this number outside, we can put it back inside. It can come in and out like a door. We just write it as log base b of x cubed. Okay, and pay attention to these instructions. Here, if it says simplify, I'm assuming it wants this a little more compact, which is what we did here with the 3. And if it says expand, it wants us to make it longer like this. So expand gets longer, and simplify gets shorter. Another word they might use is condense. Okay, and on with that. Expand. Okay, so that means get this outside, and we're gonna have 4 log base a of x, and we're done. Next one, simplify. Okay, there's a 2 outside, so I would put it inside real quick. Log base b of x squared plus log base b of y. Okay, now we do the product rule since we have a sum of log of the same base. Okay, log base b of x squared y. And we're done. This one, simplify. Okay, again, we still have a constant on the outside, which we can bring to the inside. Okay, so we have log base b of x to the 1/2 minus log base b of y. Okay, now since we have a minus sign, we can divide the top by the bottom. So we have log base b of x to the 1/2 divided by y. And alternatively, x to the 1/2 is also known as, let's write this over again real quick, log base b of the square root of x divided by y. And it's the same thing for x to the 1/3. X to the 1/3 is the cube root of x. X to the 1/4 is the fourth root of x, and so on. Okay, next one. Log base 3 of x cubed y squared z. Okay, you should be getting the hang of this by now. Since we have a product, we're gonna just sum. So log base 3 x cubed plus log base 3 of y squared plus log base 3 of z. And since we have some powers here, and we want to expand, we're going to put them on the outside. Okay, so 3 log base 3 of x plus 2 log base 3. The 2 just comes from here. Log base 3 of y plus log base 3 of z. Okay, we're done with that one. Simplify. Okay, since we have a plus sign, it's just going to be a product rule. So, oops, ln of x, y, z first. And what I was going to write is, if you don't like this ln, you can temporarily switch it out for log base e of x, y, z. They mean the same thing. Okay. Another one of these. Log base 10 of the quantity x to the power 5 divided by quantity y squared. Okay. So since we have division, we're going to use subtraction. Subtraction of logs. So here we don't have to write the 10. 10 is implied. This is going to be x to the power of 5 minus log of y squared. Okay, this is going to be 5 log x minus 2 log y. Let me close that g. And next one. This is just going to be ln of x divided by y. Since subtraction turns into division. Okay, this looks a little more complicated. So we have expand log base 10 of the square root of the quantity x cubed divided by z. Okay, as we covered earlier, we can treat a square root as raising something to the 1/2 power. So in other words, the square root of 64 is equal to 64 to the 1/2. Using the same idea here, we can write this expression as, in parentheses, x cubed divided by z to the 1/2 power. Let me just copy this here. Okay, since we're taking the logarithm of that, some even bigger parentheses, we can bring this power to the outside, like in other problems. And this turns into 1/2 log of x cubed divided by z. We're still not done yet. We have to use our division rule and our rule again later. Okay, since we're going to break down log of this thing, let's put this in parentheses real quick. So we're going to have 1/2 the quantity log of x cubed minus log of z. And again, we can break down this x cubed as 1/2 3 log x minus log z, and we're done. You can distribute the 1/2 if you want it. I think it's preference here since it's a fraction. Okay, now we're going to cover exponential equations. Okay, solve for x. 5 to the power of 2x plus 3 is equal to 30. And this is going to be a helpful problem solving tip. If you're dealing with powers, with strange powers like 2x plus 3, you should try taking the log of both sides if you can't think of it conceptually. Okay, so we're going to have log of 5 to the power of 2x plus 3. Let me change this trig so I can clear of 2x plus 3. It's equal to log of 30. Okay, so we just took the log of both sides. And since we have a power, we can treat it like a power rule and bring this to the front. So we're going to have, forget the parentheses, 2x plus 3 times log 5. Oh, and one thing to clarify, when I take the log of both sides, you can actually do whatever base you want. Here I'm just using base 10, but any base works. Okay, log of 5 is equal to log of 30. Okay, let's distribute this log 5 to see what x is. So we're going to have 2x times log 5 plus 3 log 5 is equal to log 30. This is just a constant, so subtract it from both sides. So we have 2x log 5 is equal to, You don't have to evaluate it since you're probably going to use a calculator anyway for this one. So I'll just leave it as log 30 minus 3 log 5. Okay, and finally, we're going to divide both sides by 2 log 5. So we're going to have x is equal to log 30 minus 3 log 5 divided by the quantity, 2 log 5. And if it made you happy, you could use the division rule here and the product rule to write this as log 30 minus log 125, which is 5 cubed, divided by 2 log 5. And you keep using rules from here to continue. Okay, another one, solve for x. We're going to take the log of both sides. I'm going to use log base pi just to make a point. You can use whatever you want. Just we're going to have log base pi of 6 power of x plus 6 equal to log base pi of 67. And again, we're going to bring this power to the outside. And we're going to have x plus 6 times log base pi of 6 equal to log base pi of 67. Okay, again, we're going to distribute. So x log base pi of 6 is equal to, plus, don't forget the 6 here, 6 log base pi of 6 is equal to log base pi of 67. Okay, again, we're going to subtract this constant from both sides to make way for this x. Okay, so we're going to have x log pi 6 is equal to log base pi of 67 minus 6. Let me write that. 6 log base pi of 6. We just move this to the other side. And finally, we can divide by log base pi of 6. So we're going to have x is equal to the right-hand side divided by log base pi of 6. So log base pi of 6, 7 minus 6 log base pi of 6, all divided by log base pi of 6. Okay, and that is an answer. Okay. And for one final problem, let's say you have a more complicated one with powers on both sides, like this. Let's say you have 2 to the power of x plus 4 is equal to 3 to the power of 5x plus 1. I covered this in a different video, but if you're interested, this is how it goes. So we take a logarithm of both sides as always. Log of 2 to the power of x plus 4 is equal to log 3 to the power of 5x plus 1. And we bring these powers to the outside. So we have x plus 4 log of 2 is equal to 5x plus 1 times log 3. Okay, we're going to distribute real quick. So we have x log 2 plus 4 log 2 is equal to 5x log 3 plus 1 times log 3, which is just log 3. Okay, this is where the critical moment comes. In order to solve for x, we need to put all the x's on one side and all the y's on one side. Okay, so we're going to subtract 5x log 3 from both sides and subtract 4 log 2 from both sides. So basically we're going to put this here and put this one here. So have the x's on one side and the constants on the other. So x log 2 goes that g minus 5x log 3 is equal to log 3 minus 4 log 2. Okay, and after that, we can factor out the x now. So we have x times the quantity log 2 minus 5 log 3 is equal to log 3 minus 4 log 2. And finally, to solve for x, we can divide both sides by this chunk. Okay, so we're gonna have a bit of an ugly answer, but it's the correct answer. So we have x is equal to log base 3, not base 3, log 3 minus 4 log 2 divided by log 2 minus 5 log 3. If you put that into a calculator, you will get an approximate answer for x.